Welcome back to Breaking Math, the podcast where we crack the code on even the most baffling mathematical concepts. I'm Autumn Finef.
And I'm Gabriel Hesch, your host of today's mini episode. We're tackling a concept so mind-bending that it might leave you speechless. We're diving into vast emptiness, the great unknown, nothing.
Nothingness, believe it or not, plays a surprisingly fascinating role in math. From sets with no members to the hunt for the ultimate zero. The absence of something can actually reveal a whole lot. So buckle up, math lovers. But before we begin, we have a few tiny announcements.
Autumn, they aren't so tiny.
All right. I guess you're right.
Yeah. In 2 weeks, we have a big surprise for you, episode 101. We can't wait to tell you about it, but until then, you can support us by signing up on our Patreon at patreon.com/breakingmath. We also have uploaded almost all of our episodes to YouTube. A few even have videos. So if you go to youtube.com/@breakingmathpod, you'll find our YouTube page. Believe it or not, Breaking Math is taken by another creator who I'm sure has very thoughtful things to say about math, and you'll see both our audio only as well as our videos as well. There's a video on Sora. There's also a video with my interview with Levi McLean about the math of music and neuroscience. So there'll be a lot more up there soon. Also, we have an open call. I want to let you guys all know this right now. Among our listeners, I'm sure we've got a lot of enthusiastic mathematicians and scientists and engineers who tune in. We want to hear from you. We have an open call for all, as I said earlier, mathematicians, scientists, and engineers who want to talk about their work to email us at breakingmathpodcast@gmail.com, or you can fill out a link in the show notes below. Now, join us on this mini episode of Breaking Math. We're going to break down nothing. But first, a message from our sponsors.
Let's take a minute to talk about the classic Alice's Adventures in Wonderland by Lewis Carroll. As it states, "Take some more tea," the March Hare said to Alice very earnestly. "I've had nothing yet," Alice replied in an offended tone, "so I can't take more." "You mean you can't take any less," said the Hatter. "It's very easy to take more than nothing." So, what is nothing? On the surface, it might seem simple. But as we dig deeper, we'll find that nothing has a rich tapestry of meanings across different fields. Let's start by exploring its philosophical roots.
In philosophy, nothing often refers to the absence of anything. It's a state of non-existence or the void. Philosophers have pondered this concept for centuries, debating whether true nothingness can ever exist. It's a topic that touches the very core of metaphysical discussions about reality and existence. For example, when we think about the universe before the Big Bang, we might imagine or try to imagine a state of nothingness. But what was it really? Was it really empty or just beyond our comprehension? Nothingness haunts being. An awesome quote by Jean-Paul Sartre.
Moving on to science, the definition shifts a bit. In physics, nothing might refer to a vacuum, a space devoid of matter. However, even in a particular vacuum, quantum physics tells us that there are still quantum fluctuations and fields at play. So, can we ever truly achieve nothing in a scientific sense? This remains a hot topic in modern physics. Now, if we look at mathematics, nothing is symbolized by zero. It represents the absence of quantity. Zero is a powerful concept that revolutionized mathematics and science. It's the cornerstone of algebra, calculus, and beyond, allowing us to represent and manipulate the idea of nothing in a tangible way.
Consider the following examples. In his book, Incomplete Nature by Terence Deacon, Deacon argues that the concept of absence of something can still have a very powerful effect. Deacon argues that just as the concept of zero transformed mathematics, thinking about life, mind, and other intentional phenomena in terms of constraints, that is to say, what is lacking, what is absence, can similarly help us resolve the artificial divide of the mind-body problem. A clear example of this idea is that the hole that defines the hub of a wagon wheel. The hole itself is not a physical entity, but a source of constraints that limits the possible configurations of the wheel's components, allowing the property of rolling to emerge on a global scale. Constraints that produce emergent phenomena cannot be fully understood by examining the individual components of a pattern. Emergent phenomena are challenging to study because their complexity does not really easily break down into parts. When a pattern is deconstructed, the constraints are not really active. Like there is no hole, no absence to actually observe. Imagine a hub or a hole for an axle that only exists when the wheel is rolling. Breaking the wheel wouldn't really reveal how the hub emerges. So, essentially what Deacon is saying here is that in complex systems, you have emergent property that really can only be meaningfully described or observed when the whole process is working together. And we're limited in terms of our ability to take those parts, apart and analyze them one by one. And the central theme of his entire book here is that consciousness itself, the idea of a conscious self, is something that emerges where there's an absence. There's an implied self that doesn't really exist apart from the material components, but it really only exists, at least according to Deacon here, in the interplay of our neurons and our brain and all of the mapping functions that our brain does to make sense of reality in itself. That somewhere among that ongoing process, a sense of self emerges, which is controversial to say the least, maybe a little uncomfortable. I'm not going to lie about that, but that's his idea in his book, Incomplete Nature. Now, similarly, this parallels with the concept of zero. This is where I want to talk about one of my favorite books of all time. This book was introduced to me by my little brother when he was, I want to say, in 9th or 10th grade, I believe. The book came out 20 years ago-ish, I want to say. The book is called Zero, The Biography of a Dangerous Idea, and it's by Charles Seife. Autumn, have you heard about Zero before?
Yes, a little bit.
Okay. So I'm not the first person that brought up this book to you then, am I?
No.
Okay. This is an exciting part where you see these overlapping topics in different books. And so not only do we have the discussion of what's missing in the book Incomplete Nature, but when you read Zero, the Biography of a Dangerous Idea by Charles Seife, it overlaps it very, very well. And it presents it in a unique way. So in Zero, the Biography of a Dangerous Idea, it's a nonfiction popular science work by American journalist Charles Seife. It was first published back in February of 2000 by Viking, which is a division of Penguin Random House, which is not to be confused with Random Penguin House. Sorry, the name is... When Penguin merged with Random House, they just made it Penguin Random House. Seife, who is currently a journalism professor at New York University, received great acclaim for his debut book. And this book explores the origins and the history of the concept of zero in philosophy and math and science. And major themes in the book include the perilous nature of zero, its role in unlocking the mysteries of nature as it's used in black holes, as well as its intertwining with concepts of infinity, especially as it's used in mathematics such as calculus, which is completely integral, no pun intended, to understanding physics. Yeah. So Seife's book is a chronological survey of zero. It covers mathematical, philosophical, and scientific aspects. It examines early numbering systems. It examines the Western rejection of zero, its influence by figures like Aristotle, the eventual acceptance of zero in Eastern and Islamic civilizations. And the book discusses contributions of key individuals such as Fibonacci, René Descartes, and Blaise Pascal. It also traces the evolution of mathematical concepts like calculus and imaginary numbers. Seife also explores impacts on physical sciences from thermodynamics to quantum mechanics and the Big Bang Theory. The book concludes by highlighting zeros, or the role of zero, in modern scientific inquiry and its significance in understanding the universe's expansion. There are 5 appendices and so many illustrations throughout the book to help clarify the complex ideas for readers. The book's very accessible, unlike the book by Terence Deacon, which has so many $50 words in it. I mean, I enjoy reading it. Don't get me wrong. I'm kind of a glutton for punishment when I read. I like, almost inaccessible literature and looking up all the words. But the book, Zero, the biography of a dangerous idea, is very accessible. My brother enjoyed it as a 9th grader. And it's not even that long. I didn't count how many pages. Did you by chance count how many pages are in
It was
that book?
like 130, 150-ish.
Yeah. And it gives a very accessible look at just the idea of zero in philosophy and math. So really, I recommend this book to anybody. It's very accessible. So phenomenal book. Now, I want to tell you guys really quickly about how Charles Seife describes how it's used in calculus. What I appreciate about this book is that Seife really spends a lot of time emphasizing how important zero is in the discovery of calculus and what calculus allows for. Seife implies that there's this mystic art to calculus and he goes so far as to say that it bypasses reason and goes into the realm of faith, simply because it, according to Seife, it apparently uses illogical operations such as dividing by zero, as well as summing infinite zeros to get a sum greater than zero. Now, these are not, I don't think you would find a pure mathematician today who would necessarily agree with that at a technical level, but certainly calculus was used, and it was used regularly and assumed to be true long before it was rigorously defined with, strict definitions. I mean, anytime you throw infinity into the mix, you get all kinds of weird things that, as Seife implies here, seem to bypass logic. So I certainly appreciate that. And I still think it is, I think it's not insignificant that we adopted calculus before we had a real understanding of dividing, of the break in logic. I think right now we describe it as using limits, like the limit as n goes to infinity or as n goes to zero. And that in a way, I call that a hand wavy way of technically avoiding dividing by zero. But at the same time, I don't know. I kind of feel like, Newton and others of his time kind of just swept the whole divide by zero under the rug and didn't think about it. You know what I mean? You just kind of, they just go away. So
I agree.
Yeah. And, even to this day, like the mysticism is not lost on me. Even on a computer, you can't integrate because, with machinery that uses countable elements or even pixels on a screen, I don't care, how high definition your screen is. It could be 4K or 8K. You still have a limitation there. You're still just a bunch of really, really small pixels. You can't have an infinite K screen. And calculus works under the assumption that you can have an infinite K. Oh, I shouldn't say infinite K screen. An infinite amount of something. And that's just a working assumption that happens to be very useful as we're describing instantaneous changes in time, So yeah, I still feel uncomfortable with calculus, full disclosure. And it's not because I can't integrate. I can integrate and do derivatives and understand those very, very, very well. I understand the assumption here. I'm just uncomfortable at a philosophical level with like, really? We're really just playing with infinity like it's, one of the infinity stones, literally. Okay.
I would be a little bit worried if you did not know how to do calculus and you were doing a math podcast.
Yeah. No. All I'm saying is that I acknowledge the absurdity of dealing with infinities here. Now that I think about it, we should have an infinity gauntlet, but have like, the 6 hardest math paradoxes. You know what I mean? So like Cantor's infinite series set. What would be all of the infinity stones in a math infinity gauntlet? I don't know. What do you think?
You just made my brain just go boom in the middle of this recording.
Okay, fair enough.
Oh.
Maybe imaginary numbers. I mean, those are pretty cool.
Yes.
Gosh, non-Euclidean geometry. Well, I don't know. I wouldn't put non-Euclidean geometry quite at infinity stone level epicness here. You know what I mean? I think e to the I pi
Plus
that
one.
proof, e to the I pi equals -1, or e to the I pi plus 1 equals 0 would certainly be one of the infinity stones here on your math gauntlet, where you could, snap and make new realities or something. So, okay,
absolutely.
Listeners, help us get creative here. What are the biggest math paradoxes that could go onto our math infinity gauntlet? And I'm trying not to use the word infinity too much here. Obviously, Cantor's infinite set series, you know what I mean? But just like maybe n, or maybe p equals np, that whole conjecture.
Yes.
Something about, the collapse conjecture. That would be our mathematics gauntlet here. So, okay. Hey, we warned you this would be an episode about nothing. So if you're listening to this thing, where's the substance? Well, there you go. There you go. That's exactly what we set out to do.
Precisely.
So okay. Here. Let me pass the baton on. Okay, actually no. There's actually a lot more to say here. Sorry, here. I have this awesome script here. Give me a second. Okay. Now, let's bring this whole discussion back to everyday language. When we say there's nothing in the box, we simply mean the box is empty. It's a straightforward, practical use of the word that we all understand. Sometimes nothing is the best we can do, which is an unknown. Unknown said that. I think unknown and nothing. There's the political party, the know nothings, but it's unknown who said that. In logic and computing, nothing can represent a null value, an absence of data. This is crucial in programming and database management, where null values indicate missing or undefined information. I'm going to pass the baton on to you here.
Nullus in verba, which is the Royal Society's motto, meaning take nobody's word for it. That summarizes that completely. Now,
we have sorry. Nothing more to say on that. Right?
You like the king of dad jokes right now. Now, literature often uses nothing as a theme to explore deeper human experiences. Think about existential works where nothing symbolizes nihilism, emptiness, or the void of human life. It's a powerful literary tool that evokes strong emotions and reflections. It also reflects a storm known as the Nothing, which is the main antagonist in the never-ending story. It's a power which destroys Fantastica, one of the worlds in the story, bit by bit, absorbing it. But the truth is the result of humans, which no longer believe in the world of fantasy. And without their beliefs, fantasy's disappearing, leaving nothing behind. This also kind of reminds me of believing in Tinkerbell in Neverland.
Okay.
So you must believe in fairies.
Yeah, fair enough.
So this is almost the same concept of nothing.
We're kind of like in the Polar Express, the belief in Santa Claus and all that.
It brings you to the North Pole.
Yeah, exactly.
You find the Polar Express.
Mm-hmm.
But with these big concepts, where does it really leave us? Nothing is far from simple. It's a versatile concept that stretches across philosophy, science, mathematics, literature, religion, and everyday conversation. It challenges our understanding and invites us to think deeper about existence and the nature of reality.
Yeah. We hope we hope this exploration of nothing has sparked your curiosity and made you think about this seemingly simple concept in new ways. Don't forget to subscribe and leave a review if you enjoyed the show. Join us next time as we dive deeper into another fantastic episode. Until then, I'm Gabriel Hesch.
And I'm Autumn Finev. And we can take this minisode as a perception of reality or an illusion. Until the next time on Breaking Math.